Everyone, Steve Hess from OpenBOM. Let's talk for a bit about items and product structure. The foundation of OpenBOM is the ability to manage these items and product structures. An item can be anything that's in your product, off-the-shelf part, an assembly, screw, raw material, circuit board, labor, anything. Product structures are the organization of items into assemblies that represent your product or parts of your product. To manage items and product structures, OpenBOM uses catalogs and bills of material. Catalogs organize items into categories such as electrical or molded or fasteners or liquid or labor, whatever categories fit into your company's process and make sense. An item may have many properties defined for it. Here we see that this item has part number, description, cost, vendor, lead time, thumbnail image. The OpenBOM data model is extendable and completely configurable. Formulas can also be used in the catalog to calculate cost or weight. Here in this example, I'm calculating the entire inventory cost for this particular catalog of items. An item's definition may also include CAD files or PDFs or steps or other specifications, vendors or sourcing or multiple sourcing information. A single item may have multiple suppliers or vendors. Each one may have their own costs or lead times. Here you can see three different suppliers for this particular item with different lead times. The catalog is also used to define the part numbering system and whether or not part numbers are automatically generated. Here in my sheet metal catalog, you can see I've got the part number generator turned on. And if I was to add a new item, I would get the next in my series. Part numbers can also be generated early on in the engineering and design process and sent directly to many CAD systems through our integrations. The catalog is the heartbeat of OpenBOM. Now, in OpenBOM, the bill of materials, as we discussed earlier, is a list of items. Here is a bill of material referencing items from many different catalogs. When taken together, this list of items will yield your product. When you use item part numbers in a BOM, the corresponding information is retrieved from the catalog and displayed in the defined product structure. The BOM can be thought of as the recipe for your product. How many of each item and where they belong in the BOM. In its simplest form, it's part number and quantity and structure. Each item in the BOM may have a BOM itself. This is how OpenBOM manages multi-level product structure. This lets you to manage multidisciplinary BOMs, for example, electrical, PCB subassemblies nested under mechanical subassemblies. BOM can also be used. This view in multi-level can also be used to reorganize bills of materials and work on product structure. Here I can move items up and down and throughout the product structure. There are three essential ways of viewing data inside OpenBOM. We already saw single level. We're looking at multi-level right now. And then there's flattened. The flattened view is important. You see the entire list of items in your bill of material without the structure. So here I can see exactly how many screws are used in this entire bill of material, regardless of where they appear in the structure. It's also worth noting that data in this grid can be edited, and properties up here with brackets around them indicate information coming from a catalog, and any change to the item in this context will be changed in all places where that item is used. OpenBOM automatically tracks history of changes, and you can always view them and go back. You can create revisions and snapshots of your bill of materials at certain times. So in other videos, we're going to take a deeper dive into activities like production planning, inventory management, much more. Thanks for watching.